Here in Chapter 11, we're going to talk about some of the juicier things about critical thinking, some of the short ideas that you can just kind of ingrain into your mind that make you a really good critical thinker and to be able to address some logical fallacies and errors in judgment. So we're going to jump into talking about judgment, decision making, and types of thinking. Lots of good examples in this lecture, so take good notes, jot down some terms, that way you can have them fresh in your mind. None of these terms that we're going to talk about are like overly difficult to grasp. So if you can jot the terms down and maybe just a note or two about them and memorize, 4 or 5 different concepts from this chapter, you'll be really sharp at identifying errors in thinking. So a really good chapter to prepare you for critical thinking. So some things we're going to look at today in this lecture are how good judgment decision making are related to critical thinking. We're going to distinguish the intuitive from rational approaches to judgment decision making, talking a lot about type 1 and type 2 thinking, doing that. We're going to talk about making good judgments based on probability. So, it sounds mathy, but it's really about probability, about likelihoods, about percentages of chances that things will happen, and the ways that we can go awry by having inappropriate estimations of when something will happen or how often something will happen based on what we think rather than based on the rational approach to it. And then we're going to look at judgment and decision errors and how we deal with them by de-biasing ourselves. So let's start off with the what do you think? Again, one of these rhetorical sections where you just kind of think about something. We'll kind of just broach it and answer, but not meant to be this all-encompassing idea, just something to think about to get you thinking about the types of things that we're going to be looking at in this chapter. All right, so again, from the book, suppose you are a qualified, reliable, and good candidate for your dream job. Although you were interviewed well for the job, you did not get it. You find out that the personnel director who interviewed you consulted with a graphologist or someone who judged you to be unsuitable based on your handwriting. Okay. Now, bad handwriting has its own negative merits, but unfortunately, that's not one of the ways that we can determine whether or not somebody is going to be a good hire. Unless they are somebody who's hired to take notes, then that's a valid cue, but in this case it wasn't. So the term valid cue is when we make a judgment based on something that's a reasonable predictor of some kind of outcome or success. All right, so that's a valid cue. Lots of times we don't use valid cues when we make judgments about something. Right. So an example that we were just talking about is that valid cues are not handwriting, but they're things like their knowledge of the area that they are going to go into, their skills in completing their work, the needs that they have with regard to the work, their motives for doing a good job. Those are all things that are valid cues for if somebody's going to be good at what they do. Sometimes we could use the term prejudice in the same context as valid cues, in that we think that somebody, for an unrelated reason, is not good at what they do, and we will judge them to be a bad employee or whatever based on things that are not related to the job. It could be things about their person. We've seen prejudice with regard to race, identity, orientation, ability, age, things like that are not valid cues. So we've seen that. We know that valid cues are important, but we oftentimes will rely on things that are not valid cues. So when you make judgments about things or people, make sure that you're using valid cues as opposed to not. So another what do you think that will lead us into some other topic too, but kind of also thinking about valid cues and what's a reasonable predictor of an outcome. Okay? So explain how judgment errors have caused you or other people problems. Right? So how have you made a judgment that has given you problems? Maybe it's judging a partner on whether or not they're suitable for you or the type of person that they are. Or judging the right way to get somewhere, or the right way to get something done. And we don't make 100% affirmative conclusions on things, so we can make errors, that's okay. Number 2, suppose that a basketball player has a hot hand, or someone who's on fire, and makes 4 baskets in a row. Should the coach instruct the other team members to pass him or her the ball? All right, why or why not? Okay. So if someone's hot, do they get the ball? All right, suppose someone playing a slot machine is already fed at 30 quarters without winning. Should the person keep playing because the chance of winning is increasing? Okay, interesting. And then number 4, how could you improve your judgment? Are we just destined to be the judgers that we are? Or are we people who can learn how to do judgment a little bit better? And by the way, we're using the term judgment. I know that people have this thing like, oh, you're too judgy or you shouldn't judge people. We're not talking about judging people, for their worthiness or if they're good or bad. We're really judging situations, circumstances, and likelihood that something's going to be a positive outcome in our life. So, if you're talking about judging a person, we have to make judgments on whether or not somebody is going to be kind or good at their job or a good partner or something like that. Those are reasonable judgments. We're not judging their worthiness in the universe, which is what most people mean by it. And by the way, most people just try to use an inflammatory tone and say, oh, you're being judgy, as a way to shut them down, which is a cheap tactic by invoking emotion into something like that. But, people do that. That's what they do. Okay, so we discussed it. Handwriting is not that valid cue. All right, so when we consider some of those things in the what do you think that we just looked at in terms of judgment and making sure that something's going to be good or have a good outcome, then we recognize that if it's not a valid cue, then we shouldn't be using it as a predictor of some kind of outcome or success. Okay, handwriting analysis has been seen as something that people thought was an important way to give insight into somebody's personality or whatever, and it's just not. It's not an overall predictor based on any reasonable trends, right? There are ways to determine if somebody has, a firmer grip, or if somebody tends to write letters more like pictures than letters, but that's about it. That has nothing to do with their personality, or if it does have something to do with their personality, it's phenomenological, meaning that it relates only to that person and not to a larger group of people. All right, so it's a pseudoscientific endeavor to use handwriting analysis as a way to judge somebody. So how can we improve judgment and decision making? Let's start off with a couple of definitions. Right? So a judgment is opinion about what is or what will be the status of some aspect of the world. Right? That's a very broad definition. Really, it's an opinion. It's based on some kind of estimation that we have. It's internal. We have to collect information and come up with a conclusion. All right, so judgments can be made in the context of something that is well thought out or something that's kind of intuitive or knee-jerk, and we'll get into more on that when we talk about type 1 and type 2 thinking. And then decision-making is evaluation. So you have an opinion on something, and then you evaluate some kind of option to see if it's the best course. Right, so you evaluate an outcome. If we're trying to hire somebody, we want to judge them based on their skill set, on these valid cues, and then we evaluate all the information to come up with a decision on whether or not that person's going to be the best fit. I've sat on several hiring committees, and so far so good with the decisions to hire the people that we have based on some good judgments. Obviously, there are people who we've hired before that have not worked out well, and you do the best you can. But despite your best efforts, your judgments don't always pan out when the decision comes time, and that's okay. We can make bad decisions. That's fine. But it needs to be in good faith that we considered all the available evidence at the time, and sometimes we just can't predict some things about people, right? That's okay. So decision making based on sound judgment is not a guarantee of the right decision, but it's a safe bet that you're on the right track to making a good decision based on what you can. But just relying on intuition or your gut is not a good policy. So we must enact something more than that, and that's where the judgment comes in. All right, so good judgments. From this critical thinking perspective, they are supported by good reasons. So we call that reasoned judgment. It's not just based on intuition. It's based on facts. It's based on observations. It's based on evidence. Like if we're hiring somebody, we get evidence for that person's success. So we look at their curriculum vitae, what we call a CV. We look at references. We look at their publishing history, whatever it is. We'll look at those things to see if they're good at what they do. And then we will also use these aspects that we can estimate from probability. So what's the likelihood that somebody's going to be a good employee? Well, they've been working now for 10 years. They've only had one negative review. So the likelihood that they're continuing to be a good employee seems fairly high, right? So it's based on probability, based on what we think. We don't look at the one negative review and say, oh, they've had a negative review. That means that they're probably not good at what they do. No, what that means is that maybe they had, a bad semester, or they had a class that they hadn't taught before, if we're talking about professors, that they hadn't taught before and it was a rough class for them. So whatever it was, it could have been a one-time thing and not a trend. So we base the likelihood of them being good employees or good teachers based on the probability of them doing well, not on the one aspect that showed them not doing well. Okay, so we use these valid cues and the good reasons for making a decision. Furthermore, there are lots of times where faculty will have bad reviews, and it's not based on teaching skill or anything. It's based on something else, right? And maybe it's based on a student that didn't do well in the class, so they are dragging the professor through the mud, or whatever it is. There are those cases where we have invalid cues for a negative review, and we even try to consider those when we make good judgments. So we try to make good judgments based on the available evidence, based on valid cues and sound reasoning. Okay. So one of the ways that we can learn about making judgment errors is by studying them. And psychologists have done a pretty good job of coming up with sound experimental designs in order to judge what people estimate based on intuition and as a way to determine judgment errors. So what happens is that we have these inaccurate judgments that don't objectively correspond to the way that events occur in the world. One of the examples that I use is, if you had 25 people in a classroom, what's the likelihood that two people share the same birthday? And people are like, well, geez, there's 365 days in a year. The likelihood that people share the same birthday must be pretty low if you can only pick two of the same days. And they'll say something usually like, I don't know, maybe there's only a 10% chance that two people share the same birthday. Or maybe it's only, a 2% chance that two people share the same birthday. But the reality is that it's over half. There's over 50% chance that two people share a birthday. So if you have 25 people in a room, there is a half a chance or a better than not chance that two people share the same birthday, and only 25 people in the room. There's a bit of math that goes behind it that you can feel free to look at. There's a really good video on Google. What do I sound like, an old person? It's actually on YouTube. Well, it's probably everywhere, but the video's on YouTube. And it's by a channel called Numberphile. And it talks about sharing birthdays, and they relate it to the number of people on a soccer field at any given time. And there's about 25 people on a soccer field at any given time between two teams of 11 plus 3 referees. And they do a good job of breaking down the likelihood that you will have two people share the same birthday. But it blows people's minds because they don't think that there's that high of a chance, because there are so many days in the year, and that if 25 people in the same room, then there's not a really good chance that two people have the same birthday. People would usually estimate that if you'd have to have like 180 people or so, 182 and a half people or so in a room in order to guarantee or to have a strong likelihood that two people share the same birthday. What this probability-based example is based on is an estimate of the known frequency of something occurring and the estimate of the known frequency. And the bigger the difference between what the known frequency of something is and the estimate of the frequency is, the higher error you have. So let's say that I said that, well, there's only a 2% chance that two people share the same birthday in a room of 25 people, and the true estimate is approximately 50%, it's just over 50%, then I would say that I have a big judgment error because I am 48% away from the actual estimate, from the actual probability or frequency of that likelihood to occur. Right? So I have an error there. and we can judge those using research. We can estimate those errors using research, and it's also okay to understand that you're going to make errors in judgment. So it's not like we're going to eliminate it completely, but what we're trying to do is come up with a better way to make a judgment so that we can reduce the error, but not necessarily eliminate it. It'd be nice if we can eliminate it. It's just not likely to happen. So stop and think. This is actually a pretty famous example in cognitive psychology. But what of the following treatments would you trust? A treatment that is 75% effective and would save 750 lives in 1,000 people with the disease, or that you have a disease that affects 1,000 people and a treatment would kill 250 of them. So you would have a result that was the death of 250 people out of 1,000. So which of those would you rather trust? Most people pick option A because we have an aversion to negative outcomes. And what that means is that if we frame something positively that we will save people, then we're likely to choose that option as opposed to an option where we will have people die or that people will be killed with regard to the treatment. Not because of, but with regard to the treatment. So we have this framing effect. Okay? So people prefer the positive outcome even when it's the exact same as the negative outcome. And it's not only when it's a positive or negative equal outcome, as in this case. This is the case largely when they want a positive outcome. But what's also interesting is that people who tend to be more anxious will gravitate toward a negative outcome because that's what their emotions are framing in that moment, that they're framing negativity, because people generally don't like to feel either anxious or nervous, so they tend to think that, oh, something bad will happen, or I'm more likely to estimate that something bad will happen. So whichever way you are tending toward is the way that the framing effect works. We oftentimes think about it in terms of positivity, where we are aversive to negative outcomes, but we also know that people tend to do what's called piling on, or looking for a negative outcome as a way to justify a feeling or whatever. There's a lot that goes into that. We won't get into it here. That's more of a clinical psychology thing that we can talk about in counseling and psychotherapy or something like that. But be thinking about the framing effect, that people make errors in judgment based on what they think will be the more likely outcome or the more positive outcome. Okay. Now, we've talked a little bit about it already, but we'll get into a little bit more about probability and rational judgment. This is about percentages. Rather than stopping to take time to make decisions, to work through a little bit of high-level cognitive math, people will oftentimes use intuition to make estimates about some kind of thing that can be reasonably worked out with some kind of percentage. So people will avoid working out the percentage and go based on what they think is the reasonable likelihood of something occurring. All right, we'll look at some examples in a second. These are, when we use intuition, we're usually using what are called heuristics. And we've talked about heuristics before. But heuristics are these rules of thumb, these shortcuts that we use to make decisions that work out much of the time because we normally don't have these high-risk situations, but oftentimes don't work out if you have to make precise decisions or decisions that are based on a logical but unknown method. All right, so we'll look at some of these in a minute where there are logical ways to arrive at a conclusion, but we oftentimes don't stop to think about the method used to get there. Okay. So intuition and experience are type 1 thinking, where we are using these fast decisions based on experience, based on what we already know, and we just decide in a kind of a knee-jerk reaction. Whereas type 2 is when we have to slow down and use logic, and we have to work through a solution. We have to use critical thinking. All right, most people tend to avoid type 2 thinking, not because it's too difficult, but really because people want to conserve resources, and that includes cognitive resources. They don't want to take time to think through something if they think that they can shortcut it using a heuristic like experience or something that they've already done, so they're going to do it the same way. All right, people tend to be aversive to using these cognitive resources, so there we go. Let's talk about probability for just a second. All right, so probability is really just a ratio. It's a fraction. It's a matter of how many times, or excuse me, how many ways an event of interest can occur divided by the total number of events that can occur. And we can talk about this in terms of flipping a coin. All right, so when you flip a coin, there's only two options, heads or tails. So how many ways can a coin flip? Well, the answer is just one. You can't have both sides, so it's one. All right. So the top number is 1 because it's heads or tails, so that means that there's only one option for it. Okay. And then that's divided by the total number of ways that the events could occur. It could occur one of two ways, right? It's possible to get either a heads or a tails, but not at the same time. So there are two possible outcomes, heads or tails, and then that goes on the bottom. So it's the number of possible solutions at each attempt. So if you flip a coin, it's either heads or tails, so that's one solution that it could have. And then the total number of options are 2 because there are heads or tails. So it's 1 divided by 2 is a probability of flipping a coin and it landing on heads, for example. Now, that might not be very mind-blowing. And by the way, if you want to think of another example, you could think of the likelihood of rolling a 1 on a die, right? Singular for the word dice. And the likelihood is 1 divided by 6 because you can only roll one number at a time. And if we're talking specifically about the number 1, then you can roll, there's only one chance of rolling a 1 because only one on a die. And then you divide that by the total number of possible outcomes, and that's 6 in that case. You could roll any number 1 through 6. So the probability of rolling a 1 on a die is 1 divided by 6. You could write that as a fraction, or excuse me, as a fraction, 1 over 6. You could also write it as a decimal, which is, let's see, 1 divided by 6, that's 10, 6, 1, 4, so that's 0.166 repeating. So you could write 1 divided by 6, you could write 0.1666 repeating, that would be just fine. You could do any of those things. And that would give you a probability based on the likelihood of getting a 1 if you rolled a 6-sided die. Now, that leads us into the gambler's fallacy. All right, so the gambler's fallacy is thinking that you are more likely to have an outcome based on the previous outcomes, especially when gambling. So here's an example. Suppose that you have a coin toss and you've tossed a coin 5 times and you get heads, 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 tails, heads. Okay. What's the next flip more than likely to be? Okay. Most people will look at that and they'll say, well, it's probably going to be tails because it needs to happen in order to maintain some kind of likelihood of a 1 to 2 ratio, right? So if we have 4 heads and 1 tails, you might be thinking, oh, tails is due, right? Tails is the next one that's going to happen because the other ones have happened so much that the tails needs to come up next. Now, you're not thinking of it like that, like in a type 2 way where you're like working through that. You're just thinking of it intuitively. Type 1, oh, I look at that. Oh, okay, tails is next because it's underrepresented here. It needs to balance out what we've already seen. But some gamblers will think that it has to be heads because it's on a streak. Right, so we have this hot hand thing going on here where heads comes up so much that it's going to come up again. Right, so you could argue either way that, oh, it's going to be tails, or that it's going to be heads. Tails is due, so it's going to be tails, or no, we've seen so many heads, it's going to be heads again. In reality, each toss is independent, where the next toss has nothing to do with the previous ones. We create this illusion, this kind of picture that something will happen based on what has already happened. Now, there are some events in the world that happen that can be reasonably predicted based on what has happened before, but tossing a coin is not one of them. As a matter of fact, a lot of things are not one of them because a lot of what we observe in the world are independent. Now, can we predict how well you're going to do on a quiz based on your previous quiz scores? Yeah, that seems reasonable because we have valid cues for making that determination. because you're able to study, you're able to review the material, et cetera, and that leads to the likelihood of you getting some kind of outcome, right? But tossing a coin, or if you're on a hot streak, that's probably not going to lead to a likelihood that you're going to be that you're going to continue your hot streak if you were given opportunity, like in a basketball game or something. Now, if you're, we're starting to get into something a little bit too deep. If you were already, shooting 75%, let's say free throw shooter, yeah, you're probably going to continue to shoot at a rate of 75% because that's kind of what your average free throw rate is, right? But generally speaking, if you're just really hot and let's say you've hit, 20 free throws in a row, and prior to that you'd had a 75% average, you can't just think that the next one's always going to go in, because clearly sometime you're going to miss and you're going to start to behave more like you were before, or going back toward your average, right? So there are some cases where you can think of observations as being dependent, meaning that you can predict it based on something that's already happened, but in many cases not so much. So that was a gambler's fallacy. We're going to start setting up a couple other ones by talking about some variability issues. Okay, so we're going to talk about kind of a mathy type subject, but in a real broad way. So it's kind of conceptual. All right, so let's talk about sampling variability. Lots of times when we want to know something about the world, we will look for other examples, right? So this is called inductive reasoning. We've talked about this before. So if I want to find out the amount of examples that I can find that will support some kind of idea, then I need to find lots of people who have different types of experience. Let me give you a quick example. If I want to know what the opinions of food are at a college cafeteria, I need to ask some people. Okay? So let's say that I ask 10 people, and they're all from one dorm. Okay? Now, you might think to yourself, okay, we've asked 10 people, they're from a dorm, they live on campus, they eat at the cafeteria, fine, no problem. Well, the problem with that is that it's small compared to the number of people that are actually on campus. So if I use just the opinions of those 10 people, I'm probably not going to have what we call a representative sample, right? I'm not going to have enough sampling variability in order to make an assumption about the rest of the people on campus. 10 people can't speak for 1,000, let's say. Okay. So what I tried to do in this case is find a lot of people who are from various places on campus, like maybe different dorms, maybe who are freshmen, sophomore, juniors, and seniors, maybe people who are athletes, maybe people who are part of Greek houses, and I will ask all those people about how they feel about the food at the cafeteria. All right, so I can ask all those people, and I am broaching what's called good sampling variability. All right, now, if there were 1,000 people on campus, the best I could possibly do is ask all 1,000 people. That way I wouldn't have any problem with the sampling variability, because I'd be talking about an entire population of people, right? The sample is a smaller subset of the population. So in most cases, we can't get a hold of the population, so we rely on the sample. Okay. Now, I want to get a sample that represents the population, so I do that by achieving what's called sampling variability, finding enough people with the various backgrounds that represent people in the general population. That saves me time and effort, but also gets me closer to what the actual feelings of people are on campus. In most cases, it's impossible to get the population, so the sample becomes very important. Now, the larger the sample, the more representative it is to the population. So if I had 1,000 people on campus, getting a sample of 700 is way better than a sample of 30. 700 is a better estimate for the 1,000 than 30 is. If I wanted it to be perfect, I'd get all 1,000. Okay. As I get bigger estimates of the population based on my small sample, I increase the likelihood of it being closer to the true population figures. And we call this a law of large numbers. So getting more people is a better representation of the population. Right? So again, once we have a representative sample, it will behave like the population within reason. Is it going to be perfect? No. Is it going to be close enough? If you do a good job of sampling and getting lots of different types of people that represent a larger population, and you get enough of them, then you're in good shape. One of the issues that goes into determining if you have a good sample is something called the normal distribution, which also leads us to a little bit of probability. We're not going to get into a lot of the nuts and bolts of it here. Again, this is just a conceptual approach to probability in the normal distribution, but I think that you'll be able to sink your teeth into something here. Now, if I have done a good job of sampling, let's say I've got 1,000 people on campus and I select 300 of them, which would be a good sample size generally. If I did a good job of sampling those people, I could get information from them about some kind of thing. Like if I wanted to measure how much they like the food at the cafeteria on a scale of 1 to 10, I'd be able to get good numbers. I'd get 300 people responding, get good numbers. I would have a good average, and people would have scores that kind of distribute equally to the left and to the right of the average. I'd have a good normal distribution. All right, you've seen this shape before. This is called a normal distribution curve. It's bell-shaped. Some people call it the bell curve. And this is based on SAT scores. We could put any scale down here we wanted to. Like if I thought that if I asked a question something like how much do you like the cafeteria food on a scale of 1 to 10, and the average was, let's say, a 5, I could put, there'd be 5 here, and then the scores for the different levels, maybe this is a 4 and a 3 and a 2 and a 6, a 7 and 8. The scores for the other people would kind of be distributed around this equally, so we'd be able to tell what percentages of people scored between certain other scores. All right, so this is kind of the general shape that would be made if I had a good sample that had what's called a normal distribution. This is really important in statistics to have a normal distribution. It's the way that we can make estimates about the population, and to some degree how confident we are about those estimates. And you might be thinking to yourself at this point, what are we talking about this for in this critical thinking class? It's really because when we make estimates about the world around us, we are intuitively using this normal distribution, how likely something is to happen. We might not have any of this in our minds, but we're intuiting the idea that things happen at an average rate and that some things happen above that rate and some things happen below that rate. Okay. So this slide just explains that curve in the context of the SAT scores. If you want to pause this and read through it, you may. That's fine. I'm not going to go through that for the sake of time. What I do want to talk about is this idea called the regression toward the mean, meaning that as observations increase, they tend more toward the mean. So the example is this. Let's say that a college student, and I guess I'll go back to this for the sake of context. Let's say a college student on an SAT scores a 700 on a subscale of the SAT, which is way better than what this student ordinarily would do. If this person took that subscale again, they are not likely to get a 700 again. They're likely to get a score maybe more closer to 500, maybe even lower. And let's say he retook that subscale, let's make it silly. Let's say he took it 100 times. What's going to end up happening is that even though he got a 700 on it the first time, he's going to take it 100 more times, and he's going to score in certain areas on this curve. And eventually his score is going to look more like 500. Because the more scores you have, the more they average toward the mean. We call this regression toward the mean, or they revert back toward the mean. And this works when we have large amounts of people in a sample. Let's say that we sampled, again, let's say 10 people, and we asked them, how much do you like the cafeteria food? And their scores could vary a lot. If you had 10 scores, they could vary all over the place from 1 all the way to 10. And what's going to end up happening is that the mean is not going to be stable. That means that the mean is going to kind of not be true to what the population mean would be, because these scores pull the mean back and forth. So if you had like 5 people that said 5 out of 10, and then you had 5 people that said 1 out of 10, then the mean's going to get pulled down a long ways. Now, let's say you had 500 people in your sample, and 495 of them said 5 out of 10, which is silly, I know, but let's just say that they had 5 out of 10, and then 5 people had a 1 out of 10. Right? The mean is not going to decrease by very much because those 5 people scoring a 1 won't impact the 495 that scored a 5 out of 10, because 5 people can't pull down the mean by that much. All right, so the regression toward the mean means that as you get more people in your sample, the less likely additional scores are to impact the mean significantly. Okay? So that's why it becomes important for us to look at large examples. And we do get into problems in making decisions because we think that 2 or 3 people not answering the same way as 50 people suggests that there is something wrong, or that there's something problematic about a conclusion, or that somehow those 3 scores way more than the other scores that we're observing. Right, so regression toward the mean becomes important. The mean is a strong indicator of likelihood, of tendencies, and small amounts of outliers ought not to skew our perception of what the reality of something is. You're starting to maybe sense that, okay, this looks like it could go into, maybe something like conspiracy theories, where a small group of people believe something, and we need to give them equal credit for their ideas. No, we don't, because that's such a small amount of people. Like flat Earth conspiracy narratives. Those are perpetuated by a very small amount of people compared to those who believe in something different based on rational science. And because people have this conclusion, they think that their conclusion ought to be equally weighed against the others, and that's simply not the case. Regression toward the mean is an important concept, especially when you have a large amount of people. Okay, so when we think about chances or likelihoods, you can think of some examples. Democrats and Republicans rigidly maintain differences and do not fairly examine the ideas of the other party. That's usually true. That's the confirmation bias that Democrats and Republicans have. This is not meant to be a political statement, but that's kind of the rigidity of the political tendency right now. All right, partisans are sure they are right and their opponents are wrong. Okay. Some selectively look online for information consistent with their position. So again, confirmation bias. So when we look at likelihood and chances, we think of confirming what we already know. We think of some of the ways that we can find information that proves our likelihood true. And what's curious about that is that neither is looking at the other side in order to see if they have something wrong, which, as we'll see, is a very fundamental key in de-biasing yourself. All right, so when you have a rigid idea about something, you will overestimate the likelihood that you are correct because you're only looking for information that supports the way that you think. So confirmation bias rears its ugly head again, even when we're talking about probability. We will overestimate the probability of something because we're looking for information that supports that viewpoint. So we've set the stage for talking about heuristics and biases. So again, the heuristic is a mental shortcut, not always thought through, but it's something that maybe we've learned in experience or we believe to be true. We rely on these heuristics to make decisions that are quick, type 1 type things. And then we have these biases and judgments. So the heuristics might lead us to biases, but it's not always the case. Sometimes biases are the result of using available information. Sometimes it's about using a combination of experience and problem solving, but sometimes lead us to erroneous conclusions too. So let's talk about some of these heuristics and biases for a little bit. And these are some things that can make you really powerful if you are able to remember them and be aware of them as you're going through life. So bounded rationality. So we have cognitive resources that are available to us, but they are limited. And they're especially limited when we have some kind of demanding judgment that we have to make. And what this does is it can make us a little bit lazy. And not because we're awful, miserable humans, but because we don't have the time or the energy to look at every single decision that we have to make in depth and come to the exact right conclusion based on logical thought. And by the way, some of these things that we go through in life don't need to have a lot of logical, rational thought to them. We can do just fine without them. But when we're talking about the context of critical thinking, we have to be able to engage that type 2 thinking that helps us to come up with good, well-formulated conclusions rather than just relying on what we already know or using these heuristics. Okay. So when we talk about something like judging probabilities, that demands a lot of mental resource, right? We have to be able to think of something in terms of the likelihood of it happening, the actual likelihood, not what we estimate, and to be able to come up with conclusions based on that. And it takes a lot of practice to get good at it. So it's not just about knowing about bounded rationality and how we need to use our cognitive resources to judge probabilities. We have to actually practice it. Right. So again, a heuristic that limited, the way that we conserve our limited cognitive resources that help us simplify judgments. They use rules of thumb based on experience. They are cognitive shortcuts. So the first one we're going to look at is what's called representative. And representativeness is the idea that something that looks like something else must be related to it. The way that the book says is that we treat instances as a member of some category because it appears similar to it. Now, that can be helpful in some cases, but not as many as we apply it to. Okay? So if we're going to use the representative heuristic, then we have to think of ways that it applies. That way we can be aware of how to avoid it. Okay. All right, so let's take a look at these two examples of coin flips. And in the first example, it's tails, heads, tails, heads, heads, tails, tails, heads, tails, heads, heads, tails, tails, heads. And in the second example, it's tails, 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 heads, 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 tails, tails, heads. And the question is, which one of those looks more random? Okay, and then you have to ask yourself, why? Well, if I look at those and I say, the top one looks more random because the tails and heads occur kind of alternatingly. Maybe there's a spot where 2 heads happens in a row and then 2 tails, but it looks to be like it's random. Now, somebody look at option B and say, well, it doesn't look very random because there are several times when there are long strings of tails and heads. Okay, so there aren't as many switches between tails and heads, so it must not be as random. The reality is that both of those are equally likely to occur because remember, the likelihood of getting tails on any throw is the same no matter what number of throw it is or what came before it or what will come after it. Those observations are independent. It's a misapplication of representativeness if you think that that one is more random than another. Another example of this that I'm just kind of recalling in the moment is that there was an experiment, and forgive me for not knowing what the authors were. I'm just pulling on top of my head right now, where they asked 50 people to go distribute themselves randomly on a basketball court. And so 50 people went out and took a couple of minutes, and then when they all stopped, they plotted where the individuals were on the basketball court. And what they found was that they really didn't distribute themselves randomly. They distributed themselves evenly across it. So eventually what would happen is that each person would estimate how far they were from another person and kind of start equidistancing themselves from each other. And eventually they got a bunch of people out on a basketball court who were more or less the same distance from each other. That's not really random. People didn't randomly stand somewhere. They purposefully moved somewhere. So that takes away the randomness once you start to apply thought to it. A random distribution of 50 people on a basketball court would have some people standing right next to each other, one person way off in a corner, somebody else might be in a cluster of 3 with somebody, and then some people might be equidistant from others, but that would be more random. So what we think is random is oftentimes not what random really is. So representativeness is really a tendency for us to follow what we think might be true based on observations rather than what the reality of the observation is. And that, again, that's based on that like attracts like, or that if we think 2 things go together, they might go together. So representativeness often works, which is why people believe in it so much. So the example provided here, if someone looks like an aggressive person yelling and waving a gun around, he is likely aggressive, so get away from him. Okay, so that means that if that person looks like or represents somebody else who might be acting aggressively or violently, then you would be right to lump them together in that moment. At the same time, if someone were shivering from a fever and you put a blanket on them, that would be a reasonable representativeness heuristic because they're probably cold, just like if somebody were shivering from being cold. All right, so that would be a reasonable application of the representative heuristic. However, there are some inappropriate uses of representativeness, especially in things like superstition, where if we stick needles in a doll that looks like somebody else, then we can harm that person, which is a voodoo practice. That is not a rational way to apply the representative heuristic. Another example is a homeopathic cure where you give somebody a small dose of some kind of toxin as a way to build up immunity to that toxin. I think this happens in the movie The Princess Bride too, by the way. But the example provided here is that if somebody were to ingest small amounts of arsenic, it would build up an immunity to larger doses of arsenic. So if someone tried to poison them, they wouldn't be poisoned. Well, that's not how that works, despite what people think. Arsenic builds up in the body. It doesn't get metabolized in small amounts and somehow make you immune to it. It actually builds up, and then once you have enough arsenic in your body, then it will eventually kill you. So don't do that, if I have to make that any clearer to you. But that's the way that somebody might use a representative heuristic. Another example is some people believe that if you eat jellyfish, then you can live longer because jellyfish appear to be immortal. So if you eat jellyfish or some part of a jellyfish, then you can live longer. So the base rate is how often something happens. Let's use an example of base rate that might be related to something like names. And I'm just going to throw a name out there that's a popular name and say John. Let's just say that John is the most popular male name in the United States right now. If I were to come across a random male and I didn't know their name and had to guess, it would be reasonable for me to say that their name is John because that's the most popular name. That's the name that the person is most likely to have if I had to just guess. Okay. Now, am I likely to be right? No, but it is reasonable for me to start with the name that is most popular and move down because that's the way that I have the best chance at guessing that person's name. However, base rate neglect happens when people don't use the base rate. And what that means is that they will use other information or some other information that may not even be related to what that person or to what they're observing in order to make an estimate of what is occurring. So let's say that I come across a random person and I say, oh, that person's name is Jasper. Now, I might make that assumption based on something else. Maybe I know a Jasper. Maybe they look like somebody whose name is Jasper, which, by the way, would be the representative heuristic, right? Let's say I did that. I would be violating base rate or engaging what's called base rate neglect because I would be making some kind of estimate based on an inappropriate or unreasonable bit of information. By the way, if you come across a random male in the world, the best bet you have at guessing their name is saying Muhammad, because that's the most common name in the world. So next time you are asked to guess somebody's name, just say Muhammad, and if they ask you why, you can say that's the most common name. That's the name that I have the most likelihood of getting this name right based on. You're going to be wrong almost all the time, but that's the best estimate you have if we use this. Now, are there other bits of valid cues that would help us to get a name right? Yes, for sure. But that would require that type 2 thinking where we think about the person, where they're from, what nationality they might look like, et cetera, and that will give us better information to estimating something like guessing somebody's name. Doesn't guarantee anything? No, because people can make up whatever names they want to. And there aren't always these strong trends based on the available information about the person. So we can't really know what that is. Another example of base rate that comes from the textbook. Assume it's known that 47% of psychologists are clinical psychologists and 1% are experimental psychologists. If you talk to a psychologist, you're probably better off guessing that person is a clinical psychologist rather than an experimental psychologist just based on the base rates. But what we will tend to do is we will use some information to make an inference about the outcome, especially if we know something about the person. And if we knew that the person had tendencies towards experimental psychology, and we started to think that they are more likely to be an experimental psychologist than not, then we would be engaging in this base rate neglect, because even though people have certain characteristics, we have to go with what the known distribution is. So if we thought that the person had a greater than 1% chance that they are an experimental psychologist and much less than a 47% chance that they're a clinical psychologist, we're engaging in base rate neglect. Everything in your body is going to say, well, based on what I know about the person, they're more likely to be an experimental psychologist than a clinical psychologist. That's still not the case, because just based on the base rate alone, you are more likely, much more likely, 47 times more likely to come across a clinical psychologist than an experimental psychologist. So what's the solution to this? You can ask what they are. You don't have to guess. But silliness aside, the solution is to revert back to the base rate to make your estimate about something, rather than relying on some kind of other information that may not be exactly related to the actual statistics or the distribution of the people that you're talking about, as is in this case. Another example of this is what's called the Linda problem. And this kind of goes along with the base rate neglect example, not the example itself, but the base rate neglect phenomenon. And it's something a little bit different, but you're going to see based on this example how the two examples flow together. So Linda is a 31-year-old single, outspoken, and very bright person. She majored in philosophy, and as a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which description is most likely to be accurate? Linda is a bank teller. Linda is active in the feminist movement. Linda is a bank teller and active in the feminist movement. So if you look at those, you can kind of think, okay, Linda does appear to be active in the feminist movement, so it looks like B is a good answer. Maybe she is a bank teller. It doesn't give us information on that in this specific snippet. But you also might be thinking to yourself, well, Linda's probably a bank teller and active in the feminist movement. Active in the feminist movement probably doesn't pay the bills, so she's got to have a job. So she's probably, most likely, she's both of those. Well, the reality is that that's called a conjunction fallacy, thinking that just because we have more information, that increases the likelihood of some kind of description, okay, that somebody belongs to two or more categories. Okay, so usually people will think that Linda is a feminist and a bank teller, but they won't realize that it is not as likely. That's not the most likely outcome. The most likely outcome is that she's a feminist, because when you have a conjunction fallacy, it suggests that a combination of being in two categories has more likelihood than being in only one category, which is not true. The probability of being in two categories is always less than the probability of belonging to one category, or that the events occur separately, which is best demonstrated by this Venn diagram. Okay, so we have people who are bank tellers, we have people who are feminists, then we have people who are feminist bank tellers. This overlap can never be bigger than the likelihood of the two events happening separately. So in this example, A and B could theoretically be equally likely. B is probably more likely than A, but C is definitely less likely than either A or B, even though most people will pick C as the most likely description of it. Even when you have information that supports your decision, it is not most likely. It might be very likely that she is both a feminist and a bank teller, but it's not more likely or most likely that that's the case. So how do we get away from these biases that we just talked about? Well, we do this thing called debiasing. That sounds easy, right? If we have a bias, we need to debias it. So what we're trying to do by debiasing is we figure out a strategy that helps us to reduce our bias, right? And if bias is a way to systematically distort judgment, then we have to figure out a way to address the systematic issue that we have, which can be really hard, by the way, because systematic means that it happens automatically and in many different contexts. So you have to be able to have this debiasing hat on as you are going through many different types of experiences in your life, especially when we're talking about critical thinking and psychology. So how do we debias? We have to estimate randomness. Okay, that means that we have to understand that random sequences do not always have a lot of skips. Okay, that randomness does not mean that things are equally distributed or that things happen at a certain rate that seems to be random. That random is just random. It's not predictable. Okay. We have to understand that the gambler's fallacy and the hot hand don't really work because each trial is independent. So just because you're in a dry spell does not mean that you're going to have a hot streak. Just because you are that you've lost a lot doesn't mean that you're due to win. So each observation is independent. Okay. And then we have to be aware of the conjunction fallacy, knowing that the probability of two things happening together is not greater than each happening individually. So we need to be able to debias and be aware of these biases that we have so that we can more readily critical think about the relationship between events happening and whether or not they are independent. And understanding that randomness does not mean equal distribution or a pattern. So let's flip over to the availability heuristic. And the availability heuristic is about being able to recall or make judgments based on information that is, well, to use a cognate, available or more easily accessible in your mind. Okay. Usually we are able to think of examples that are more vivid in our minds, especially when given a contrasting set of options to choose from. So one example that I see in clinical worlds is when we are get prescribed medications, especially for mental health issues. A lot of the times the medications that the prescribers will use are those where the reps come in to sell the drugs or to market the drugs to them, where they get free samples, they get pens and stationery and stuff from the drugs. Those are the drugs that are more likely to be prescribed, even if they aren't the best drug for what's going on with the individual. It's not that they're prescribing the wrong drug, it's just that they are defaulting to one that's available in their mind, right? So they're recalling that the drug rep came in, they're talking about a particular drug, and all of a sudden that's the one that gets prescribed most. Surprise, surprise. Another example is, are you more likely to die from a tornado or from an asthma attack? More people are like, well, geez, tornadoes are deadly, and if you get hit by a tornado, things get knocked down, it's devastating, so you're more likely to die from a tornado. The reality is that many more people are likely to die from asthma than they are from a tornado, right? Kind of like this, what's a more dangerous animal, a shark or a mosquito? You might think, well, geez, sharks are dangerous. They have teeth and they'll bite you and everything. Yeah, that's true, but mosquitoes kill millions of people per year, and sharks only kill dozens of people per year, right? So there's a huge difference between how many people mosquitoes kill versus how many more sharks kill. Now, obviously, we're like, well, mosquito bites don't hurt. No, but they also transmit disease. And the diseases that are caused by transmission through mosquitoes will kill people. So we make decisions based on what seems more vivid in our minds, what's available to us, the information that we have access to, especially when we're talking about the difference between mosquitoes and sharks, or the difference between asthma and tornadoes. Okay? So stop and think question. Which city has a larger population, Boise, Idaho, or San Antonio, Texas? So depending on what you know about these two cities, will factor into what you think about them. But if you don't know much about them, you might be swayed toward one or the other. Okay? You probably correctly answered that San Antonio because the information about San Antonio came more readily to mind, like it has a sports team, or that Texas is a big state, San Antonio is in a big state, so it must be bigger. That would make more sense than Boise, Idaho. Even if you're familiar with Boise, Idaho, and not San Antonio, you might estimate that San Antonio is bigger just because it's from a bigger state, et cetera, et cetera. So that helps you to make the correct decision, but only because of what is kind of generally known about those two cities. If you're like, well, I don't know, I have no idea which one's bigger. If you had to guess one, you might use other information that's not related to the size of the city, but maybe something that's ancillary to it, like maybe, well, I don't know, I'm more familiar with San Antonio, Texas, or something like that. You probably use that information. If you chose Boise, it's probably because you weren't sure and you gave just any kind of guess, or maybe you thought to yourself, well, I don't know, maybe am I supposed to say Boise because it seems like it's not the right answer, whatever it might be. You picked it for some kind of reason, again, not related to the actual evidence for which city was bigger, which is part of what the availability heuristic is. It's a shortcut that gets us to an answer that might not be based on the reality of the information that you are weighing. When you favor something that comes more readily to mind, you're actually contributing to the confirmation bias. Okay. You will have information that supports the way that you think. And if that pops into your head and it makes sense to you, you will agree with it. So you're engaging in your own intrapersonal confirmation bias. You're not looking for outside evidence, but the evidence that you can think of supports the way that you think. And that's kind of a super silly way to engage in a confirmation bias, because your brain will automatically try to find the things that it already supports, right? That's what your brain's there to do, is to support what you already believe or use your own memories. It would be odd if you had these conflicting memories all the time and said, well, wait a second, that's not what I remember, so that must not be what I think anymore. We don't usually go through that process. So we have this internal confirmation bias that happens. Another instance of a thinking error is when people use vivid details. So it's not only about what we remember, it's also about what is presented to us that contributes to the availability heuristic. So participants serving as jurors in a mock trial were more affected by the prosecutor's statements that vividly described the evidence than by more pallid descriptions of the evidence when tested 2 weeks later. So this information was presented to them. They developed a sense of what was going on in that moment. Right? So in that moment, they were susceptible to an availability heuristic because they were more sensationalized to what was going on. And that also supported the original notion about the availability heuristic, that we remember that because it was more vivid. So when they were fed vivid versus pallid bits of information about some kind of mock trial, they remembered differently, or they were affected differently by the prosecutor's statements even after the fact. So when we have an availability heuristic, there is a way for us to de-bias ourselves against availability. Okay. So we have to remember that when things are presented to us vividly and frequently, then they come to mind more easily. So think about the way that news is presented to you, right? It's repetitive. They use inflammatory language. They use terms that are sensationalized. When that happens, you have to put on your cap and say, wait a second, this is designed to make me remember it in a certain way. I need to be careful of what I remember and separate the reality of what's being claimed from the way it's being presented. We also need to think of the opponent's point of view and consider the alternatives. Right? So we have to think about, okay, what is that person claiming, or what are some alternatives to what this person is claiming? So you have to be on your feet. You have to be aware of what's going on with the conversation, with an argument that's being made, and recognize that what you're thinking about it might be biased, and that you have to consider the other viewpoint, because the thought that you have is going to support the way that you already think. And if we're going to be critical thinkers, we have to think of what the alternative explanations might be. Then the last thing is finding the information. Take the time to find out the truth of the information. Take some time to research. Don't make snap decisions based on what you remember or what's most vivid in your mind. It's okay to have those in mind, but compare those and take the time to find the alternative. So it's not just about thinking of the alternatives. We have to find the time to do it, right? So, and if you can't find the time, don't make a decision. Don't make a decision just because you feel rushed into doing it. Now, anchoring and adjustment heuristics are kind of interesting. there have been some good bits of research out there in cognitive science that have helped us understand that anchoring and adjustment exists. It's still interesting as to where each individual starts their anchoring for different situations or why they choose them. The best estimate we have is that it's personal, but we have found that when we offer people numbers to anchor their decisions on, they will use them even if the numbers have nothing to do with what they're anchoring. Here's an example from the text. There were two groups of people in a quasi-experimental design who were asked these questions. Is the proportion of all African countries in the United Nations greater or less than 10%? And then another group was asked, is the proportion of all African countries in the United Nations greater or less than 65%? And the responses that they got were anchored on those two values. They weren't just, it's like 50%. It's not like each of them said 50% or each of those two groups said 40%. The responses that they got from each of the two groups were related to those arbitrary numbers of 10% and 65%. Okay. So what happened was that the group that was told 10% had lower estimates as a group compared to the group that were given 65% as the starting point. Right? It's an anchoring effect. We're able to anchor people's responses based on what they were given as their starting points. Here's another example that I've seen in my research methods class. We asked a question, how satisfied with you with parking on campus? And we had two groups that asked the same question, and one group said, we're going to ask this on a scale of 1 to 7, okay, where 4 is the middle answer. And then another group asked the question on a scale of -3 to +3, where 0 was a neutral answer. What we found was that on the scale that was -3 to +3, most people answered below 0, which was very interesting. It wasn't the average, it's that most people actually answered below that because they felt that parking on campus was really awful. They didn't like it. So it wasn't even neutral to them, it was negative. But on the question that was answered on a scale of 1 to 7, the average was 6, where most people were happy with it. Now, we couldn't necessarily explain why people answered the way that they did because we didn't ask an additional follow-ups and the surveys were anonymous, so we couldn't follow up if we wanted to. But there was a very big difference, and the best information that we had available was that there was an anchoring effect, where the people who saw the negative numbers thought negatively about parking more than the people who had the positive numbers only, the 1 to 7 scale. Right. So their estimates were definitely affected by starting values, not just in terms of what they estimated, but it seems as if we actually not changed the mind. We allowed people to effectuate their feelings about it more readily when there was a scale of -3 to +3, just because that negative thing came in there and the 0 being the neutral point. So we've seen that, and the anchor was based on what we provided to them as researchers. Probably need to do a bit of research on that to see if we can't replicate that, but that's for another class. Okay. So how do we de-bias ourselves with the anchoring effect and adjustment? Well, what we do is we look around for other information on which to base your judgments. So not just based on a scale, not just based on a starting point, whatever it is. Think about like if you're applying for a job interview and they'll ask you something like, okay, what would you like your starting salary to be? And you offer them a number, they're going to base your starting salary on that number. So they're going to let you anchor yourself. So that means that you have to look around for other information. And what you can say in that case is, well, I'm wondering what the budget you have for this position is, because I'm uniquely qualified for this position. I have some skills that'll be very helpful to this company, and I'm just wondering what the budget is for this position. So you can put the ball back in their court or look around for other relevant bits of information, maybe looking outside of the company for what an average pay scale might be for a position like yours, and say something like, well, based on what I've been able to find from different different research firms, it looks like this industry is, hovering around a starting salary of $70,000. So I'd like to be in the $70,000 to $75,000 range based on what I can bring to the table and what the average starting salary is. So you can take away that anchor by offering some information that is outside of the parameters of what you're talking about in that moment, but in something that is empirical and research based. Yes, it takes an effort to do that, but that's why we're talking about critical thinking. It's effortful. It takes thinking. What you can also do is make larger adjustments from starting values that others provide. So if somebody offers you a starting value, somebody offers you an offer on your house, and it's, let's say, $100,000, and you want $200,000 for it. You're not going to just say, well, we'll meet in the middle at $150,000. And say, no, I'm looking at $190. That's the lowest I will go. So being able to make larger adjustments from the anchor that's provided to you, or not considering the anchor at all, can be helpful too. So just be careful of the information that people provide you and what they're trying to start off with, because it's easy for you to start negotiating and forgetting about the fact that there are other pieces of information that are relevant in making a decision other than the information provided to you by another person, for example. So the last thing we're going to talk about is metacognition and overconfidence. So metacognition is awareness of our own thinking. Okay. If we're not monitoring ourselves, then we're going to have some faulty thoughts that we're not going to be able to fix because we're not paying attention to them. We have to be thinking about our own thoughts. That's what metacognition means. It means thinking about thinking. Okay. We all have a blind spot, and that's not a bad thing necessarily, but we can be aware of it. And if we are aware that we have blind spots, then we have responsibility to do something about it. All right. So generally, people have a bias blind spot, meaning that they are blind to their own biases, and a couple of them are the skilled and unaware effect. Usually, people who perform poorly are overconfident in their skills. Okay, this is known as the Dunning-Kruger effect, and a short way of saying the Dunning-Kruger effect is the more you know, the more you don't know. When you think about learning a topic, generally when you first start out, you're pretty ambitious. You're like, yeah, I get this. This is fun and exciting. Then all of a sudden you learn a little bit more information. You're like, wow, there's a lot more to this that I didn't know. And the further you go down that trail, you start to learn about all the nuances and the tricks and everything about the thing that you're learning. And at some point you realize, wow, there's a lot that I don't know. But the unskilled person, the person who doesn't start to learn, who doesn't dig into something, they don't become aware of what they don't know. And those people are overconfident. At some point, people who are so good at what they do, they will actually underestimate or they will lack confidence but still overperform, because they start to develop the sense of, oh, I understand that I don't know everything about this, so I'm going to estimate that I don't know something and be careful about it. And they will overperform because they will take the care to do something well, knowing that there's something that they don't know about it. Okay. So what we can do about that is help people to reason well, to be aware of these unskilled and unaware effects, so that we can reduce overconfidence and performance. Now, we want people to be adequately confident, but not overconfident, because that leads to people being seen as unskilled and unable to perform a task. So we want people to have a reasonable sense of confidence that they can do something, but not that they know everything. Right? Overconfidence can be very problematic. Okay. And then let's finish up with the hindsight bias. Hindsight bias is a type of overconfidence where when something has happened, we can look back on it and we can then estimate what we think we should have known, which is not a great way to go back and look at something as if you should have known something, especially when something bad happens to somebody. Like, well, you should have known that would happen. Well, yeah, I know that now, and you know that now, but in the moment, neither one of us knew that. I knew it all along is a statement that goes along with it. Hindsight bias is when you have 100% confidence in something only because it's already happened. So it really is an overconfidence error, but it's the hindsight bias where you have all the information and then you make a decision, which is not how things work. Then we start to get down on ourselves for making bad choices because we should have known something, or I knew it all along, which is when people say that, well, I knew that all along, I should have done something different. Okay, fine, but you didn't know it all along. It's the bias that we have. There is a blind spot that we have for some information, and we can't hold ourselves accountable to knowing every little thing. Now, are there things that are reasonable for us to know about? Yes. Are there things that we would have known about had we engaged in critical thinking? Yes. But generally, it's not a fair thing to go back and say that we should have known everything. Really, you sound like a pompous person if you just say that you knew everything all along. What it really says is that you didn't care to do anything even though you knew something. So it kind of makes you sound like a jerk, especially if something bad happened. Anyways, how do we debias that? Well, we consider alternative outcomes that could have occurred, okay, which is kind of helpful. But what would be most helpful is using metacognition in a moment. Right, so we have to prevent the hindsight bias by using metacognition, being aware of what's going on, looking at outcomes that might be more likely, looking for alternative explanations for what's occurring. And really, because once we've engaged in the hindsight bias, we can't do anything about it. So the best thing to do is to learn from it, and that helps us to increase our awareness. So being aware of the hindsight bias and being able to decrease it going forward is the most reasonable thing to be able to do. Plus, it helps to ward off regret, right? You don't want to regret something, so you kind of want to be aware of what's going on going forward. So, so we've talked about a lot in this chapter, and really what it comes down to is, does type 1 thinking have any place? Remember, type 1 thinking is that instant experience-based gut reaction type thinking. Does that have any place? The answer is yes, it does. There are lots of times where making quick decisions based on intuition can be very helpful. People who are firefighters, EMTs, have to oftentimes make quick decisions. Being an athlete, yes, type 1 thinking is very important. For you, type 2 thinking is also important, being able to be analytical, work through things, make decisions that are important. Those are okay to do too. So there is a time and place for type 1 thinking. There is a time and place for type 2 thinking. Again, that metacognitive process that we talked about, being able to think about thinking, will help you know when it's time to do one or the other. If you're worried that you don't make great knee-jerk decisions, practice. You know, just like an athlete would practice for a game to be able to make that quick decision without thinking, we can practice situations. Relationships are good places to practice, good, safe relationships, I should say. Not to practice everything, right? We want to be careful. You don't want to, run somebody through the ringer practicing being a critical thinker. But it is okay for you to talk to people about, geez, I think that I might have been overconfident here, or I think I may have overestimated the randomness of the situation, or whatever it is. You can do that, and you can think about it in a process. You can use internal dialogue. You can work through it with somebody. But those are all ways to help you become good thinkers. All right, I've had enough of this. It's been almost an hour and a half, so we're going to call it quits there. Thanks for hanging out, and I look forward to seeing you next time.